to find the time interval right here. Find the time interval during which the velocity of the particle is at least 60 miles an hour. So take a look here for a minute. The velocity of the particle is 60 here and here, right, at those 2 points. But the question isn't asking for when it is equal to 60. It's asking for when it's at least 60, so greater than or equal to 60. So you say, you find these points, right? We're going to find these points, analyze graph, intersection, this one, and then do the same thing for the other one. You have to be super quick with these, right? And those are the only points, right? Because it's from 0 to 4, okay? So it's less than or equal to 60 between 1.866 and 3.519. Is that true? Yes. So you write that up over here, okay? You say it's V is equal to 0 at t equals this and t equals that. Now what I also did, because the second part of the question is saying find the distance traveled by the particle over that time, I also set them equal to A and B in the same process, right? I defined it as A equals this and B equals that. So now when I go to my function or my graph, I can store this as A, and I can store the other one as B, okay? And I can graph B. Okay, so the total distance traveled then, so I said V is greater than or equal to 0 on A to B, and the total distance traveled is from A to B of this, which is that much, okay? So now let's take a look at D. At time t equals 0, the particle Q is at position x equals negative 90. So xq of 0 is negative 90. Using the result from part B and the function VQ from part C, approximate the distance between the particles at time t equals 2.8. So I want to know where is the particle at 2.8, where is P at 2.8, where is Q at 2.8, and then subtract them. So what did happen in B? In B, I found this. What is this that I found? What's 0 to 8 VPT dt? What have we found? Not, yeah, it's area, but what, if you integrate velocity, what do you get? So this is the distance that the particle traveled from 0 to 2.8 seconds. Okay? So the final, okay, so the position of the particle at 2.8 is x0 plus that. Okay? Oh, I'm sorry. No. Oh, yes. So the particle at t equals 0 was at 0. Okay? So this is 0 plus, how much was it? 40.75. So it's now at 40.75. Okay, well, what about the other particle? Where is that one? xq of 2.8 is equal to xq at 0 plus 0 to 2.8 vq of t dt. Okay, what's initial position? Negative 90. Plus, you put in that integral and you get 135.937. So this is at 45.938. Okay? 938. Questions? So now what's the distance between them? You subtract and how much do you get? 5.188 meters. Okay? Yeah, 45, sorry. Questions? Okay, so question 3. Let's go to number 3. Okay. So question 3 talks about this. Okay. Okay, so question 3. We have a continuous function, right? That's important. We're underlining that part. Defined on the closed interval from -6 to 5. The figure above shows a portion of the graph consisting of 2 line segments and a quarter of a circle. So they tell you that so there is no doubt in your mind that this is a circle, that this is a segment, this is a segment, and that's a quarter of a circle. The circle is centered at the point 5, 3. It is known that the point 3, 3 minus root 5 is on the graph of f. So the center of the circle is 5, 3. This is the center of the circle. So how much is the radius of the circle? 3. Okay. So part 1 or part A. If -6 to 5, f of x dx is 7, what is the value from -6 to -2 of f of x dx? Find the work that leads, show the work that leads to your answer. So the area from -6 all the way to 5 is 7. Okay? So that's including the part shown on the graph and the parts that are not. So remember, when we say integral, it's the region between the graph and the x-axis. The graph and the x-axis. So it's all of these regions here. All right? So what we have to do is we have to find all of these areas. Yes. Okay, so what's the area of this region to the left of the y-axis? 0. Okay? So here area is 0. And then here I've got this triangle here, and the area is equal to 2. Right? Here, right, I want to find this area. So do you see how it's got to be that square minus the quarter of the circle, right? So the area here is the square minus a quarter of pi r squared. So this is equal to 9 minus 9 pi over 4. Cool? Questions?
Why is the area of the triangle 2?
Half times 2 times, oh, is it 3? Oh, I'm sorry, I missed the part. I'm so sorry, I missed the part. So look, this and this is also 0.
Oh, okay.
So now you've got just this trapezoid, which is 2. Yeah?
How do you know that it's canceling each other out?
This area underneath and this area up there. One is negative and one is positive, but they're equal amounts of area.
And it's the same one.
And it's the same here. Okay. So then what we have here, like Ben was saying, is 7 minus, what was it? 9 minus 9 over 4. No, 11 minus 9 over 4. Which is equal to, how much? 9 pi over 4 minus 4. Okay? All right, next. Okay, so evaluate, look at this one. Look at what we're going to evaluate here. Okay, so this is what we're going to evaluate here. So this is the integral of something plus something else. So you know what I'm going to do is I'm going to split up those integrals. So I'm going to say this is 2 times the integral from 3 to 5 f prime of x dx plus the integral from 3 to 5 4 dx. Okay, so this is 2 times. How much is this integral? What is that? What's the integral of f prime of x? F of x from 3 to 5. Okay? Plus, how much is this one? This is 4 times 5 minus 3. Right? The integral of a constant. So now, this is 2 times f of 5 minus f of 3 plus 4 times 2. Okay, so 2 times, what's f of 5? 0. Love those zeros, man. Minus f of 3. How much is f of 3? Yes, you're right. You can't tell, but then you're like, oh my God, are they seriously asking me to like figure that out right now? Then you go, wait, yeah? They put it in the question.
I was wondering the whole time, what was
What?
the purpose of that?
Yep. Isn't it so nice of them? Yeah.
That's really
Yeah, how compassionately nice of them. Right? So 3 minus root 5 plus 8. Yeah, I know. At the end of the day, that's 2 plus 2 root 5. Yeah. So that's 2 plus 2 root 5. So now I have a secret for you. You ready for my secret? Okay. On the AP test, if you left it like this, it would be okay. As long as it's all correct. All right? Yeah.
When you went from the f, how did you go from the f prime of x to the f of x?
So the integral of the derivative is the function. They cancel each other out.
Yeah.
But then you gotta do like b minus a.
Right.
Yeah. 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 Okay. So. Huh? Oh yeah. So the function g is given by this f of t dt. Find the absolute maximum value of g on the interval from -2 to 5. Okay, so first of all, what is this? Whenever you see integral, it's what? Area. Area. Okay. So this is the area from -2 to some value. Okay? But that's all fine. We want the absolute maximum value. How do you find the maximum of anything? What do you do?
Set it equal to 0.
What equal to 0? The derivative equal to 0. Now, but if you want to find the absolute maximum on a closed interval, that's the, right? But that's not the MVT, that's the EVT. Who said EVT? It's so hard with these masks because I can sort of tell where the noise, I can always narrow it down to the closest two. So, find the derivative, set it equal to 0, get the critical points, then evaluate it at the critical points and the endpoints, and we find our maximum value. Yeah, remember? Okay. All right. I don't know why I'm yelling, but it's so exciting. Okay. Okay. All right. So let's take a derivative. So what's g prime of x? What is g prime of x? Of that one? If you take a derivative of this highlighted thing, what do you get?
Oh.
F of x, right? Because it switches. F of x. And you want that to equal 0. Okay, where is f of x equal to 0? At a lot of places. Well, what's one of them? -1. What's another one? 1/2. And at 5. Okay? So x equals -1. What did we say? 1/2 and 5. Okay, so those are identifying the critical points. So far you have been eligible for 2 points. One is to set this equal to 0. One is to identify these points. And now the third part of this is you have to evaluate at the critical points and the endpoints. All right? So we have to do, this is the endpoints now, g of 2. So what's g of 2? I'm sorry, not g of 2, g of -2. So that's from -2 to -2 f of t dt, which is 0. Okay? We also need g of 5. We found g of 5, didn't we? Right? We found g of 5. G of 5 is this entire area, right? We just found it. What was it? It was
Wait, where did you get
11 minus 9 over 4. Yeah.
where did you get G of 2?
G of -2. So these are the endpoints.
Oh, okay.
Yeah? Okay, so g of 5 is 11 minus 9 pi over 4. We found that in part A. Okay? Now, you also have to do g of -1 and g of 1/2. Yes. It's a half, right? The area until -1 is a half. And then what's g of 1/2? So the area until the 1/2 here. These are 0, another -1/2. Okay, so what's the highest number we got here? That's definitely this 11 minus 9 pi over 4. Okay? That's much bigger than 0 and a half and a -1/2. So sorry. So this is the maximum. Okay? So we're going to say, what are we going to say? Find the absolute maximum value. The absolute maximum value is g of 5, which is 11 minus 9 pi over 4. Okay, so 1 point for this, 1 point for this, and 1 point for all the other stuff, and do this. So if you did this, and then if you did a timeline, or not a timeline, a sign chart, and you did, like the arrows, and you did it that way, you would get no points for this part. Okay, look at this one. Ooh, look at that one. What? What is that? Okay, let's put in a 1 here. Yeah, let's see. Let's see what we get. Okay, so 10 to the 1, 10, fine. Minus 3 times f prime of x. What is that? What's f prime of x? That's the slope where? At 1, right? So this is minus 3 times f prime at 1 over f of 1 minus arctan of 1. Okay, so this is 10 minus 3 times, what was f prime at 1? It's 2, right? Because you go up 2 over 1. Over what's f of 1, you say? What's f of 1? 1. minus what's arctangent of 1? Say it again. Pi over 4, because that is the angle where the tangent is 1. Okay, okay. Right? So how much is that? 6 over 1 minus, I'm sorry, 4 over 1 minus pi over 4. And you know what? Just leave it like that. Leave it like that. Don't do any other, acrobatics and stuff. Just leave it like that. This is a 1-point problem. Yeah, right? So do you see how it's kind of fair, right? Like, because there are some like challenging ones that you kind of like need to crank out, but some are like, okay, like that's like out of nowhere. Yeah. Okay, now Ben's been looking forward to this one forever. Yeah.
I hope it's good.
I mean,
This is actually doing a couple of these last night.
For fun.
No, someone needed help in Calc.
Oh.
Doing like the rate of change and stuff.
look at that.
But I bet this is not.
And so this one was on one of your tests, remember?
Optional.
Did we talk about this? Yeah.
Yeah, it was optional.
Okay. So a cylindrical barrel with a diameter of 2 feet contains collected rainwater, obviously not in LA, as shown in the figure above. The water drains out through a valve, also not shown, at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by this. So this is dH dt, where h is measured in feet and t is measured in seconds. The volume of the cylinder with the radius r and height is this. Okay, so most of like they will give you these, right? Like, so like you need to know like what the area of a triangle is and what the area of a circle and a trapezoid is, but these will be given to you. Okay. Find the rate of change of the volume dV dt with respect to time when height of the water is 4 feet. Indicate units of measure. Okay, so maybe I'll do part A over here. Okay, so if I want dV dt, I need to start with the thing I'm taking a derivative of, which is volume. V is pi r squared h, right? So in these things, right, of these quantities, is there any that is a constant?
Yeah.
What? Which one?
The radius.
The radius is a constant. How much is the radius? 1. Radius is 1. So before you take the derivative, plug it in. So V is pi times 1 times h. So V is pi times h. Okay. dV dt is equal to pi dH dt. All right? So, what is dV dt? What is dH dt though? Yup.
1/5.
And then h is 4, right? It tells us in here that h is 4. So this is equal to negative pi over 10 times root 4. So dV dt is negative, how much? Pi over 5. Okay, and yeah, the volume is decreasing. Okay, now it says to indicate units of measure. So what units of measure are we going to put in here? Feet per second? So what are we?
Per second, per.
No, what have we found? It's dV dt, so the change in volume, cubic feet per second. Okay, so this is the first one where we explicitly saw one that asks for units of measure. So I have all these notes here. It looks like I went to a webinar for this one too. So if there is no work, they gave 0 points for this one, if there was no work. That's all I have here. Okay, so it's 1 point for this, 1 point for saying this, and 1 point for this answer. Okay, next one. When the height of the water is 3 feet, the rate of change of the height of the water with respect to time increasing or decreasing? The rate of change of the height of the water increasing or decreasing. So what quantity is that? The rate of change of the height of the water, that's dH dt, correct?
Decreasing.
Okay, so hang on. You don't want to know what dH dt is. You want to know, is dH dt increasing or decreasing? So forget about the whole dH dt thing. If I asked you, is f of x increasing, how would you be able to tell me if it's yes or no? The derivative would be what? Positive. So if I ask you, is blah increasing, you have to take the derivative of blah and see if it's positive or negative. So is this increasing or decreasing? You want the derivative of this, and you want to see if it's positive or negative, right? Okay? So part B, we want to take d dt of dH dt. Okay, so that's d squared h dt squared. And you know what? I'm going to write that up here because I'm going to need room. So how much is that? So let's take a derivative of that. That's negative 1 over 10 times 1 over 2 root h. And when is this happening? When the height of the water is 3 feet. So at h equals 3, d squared h dt squared is equal to negative 1 over 20 root 3, which is how much? Oh no, hang on. What did I miss here? Sorry, this is how I know I'm getting hungry. What did I miss here? So when you take a derivative of this, you have to multiply it by dH dt, chain rule, okay? So times dH dt. Which one, the derivative? Okay, so I'm taking a derivative of this in the box, okay? So it's negative 1 over 10 times the derivative of the square root of something. So the long way is you could say this is h to the power of 1/2. Then bring in the 1/2, and it'll be h. Or let's just memorize that the derivative of root x is 1 over 2 root x. Okay, so it's the derivative times dH dt. So this is negative 1 over 20 root h times negative 1 over 10 root h. So look at what happens. The root h's cancel, and this is just positive 1 over 200. So you say, since d squared h dt squared is greater than 0, then dH dt is increasing. Yeah. Yeah. Okay. All right. C.
The reasoning would just be because the derivative is positive.
Because d squared h dt squared is positive. Okay. So here there is 1 point for this part, 1 point for this part, and 1 point for this part. Okay. C. At t equals 0, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. Okay, so we're going to take dH dt. is equal to negative, what was it? 1 over 10 root h. And use separation of variables. So, here we go. dh over root h is equal to negative 1 over 10 dt, and integrate. Okay. Okay, so this one, this is like the integral of h to the negative a half, right? dt, or dh, which would be what? H to the half times 2, right? Because divided by 1/2, which is a 2. So this is 2 root h is equal to negative 1 over 10t plus c. Okay.
But why did you change the t to root h?
Huh?
Why is it dh, dt, and then below that's dh?
We did separation of variables. Everything with h came on this side. Yeah. So now let's put in the initial condition. At t equals 0, h is 5. So 2 root 5 is equal to c. That means 2 root h is equal to negative 1 over 10t plus c, plus 2 root 5. Okay. Divide everything by 2. Root h is negative 1 over 20t plus root 5. And we square both sides, so h of t is negative 1 over 20t plus root 5 squared. Okay.
Can you explain how you solve for c?
Yeah, so it tells you at t equals 0, h is 5.
Yeah.
So t is 0 here, and h is 5. So 2 root 5 is equal to 0 plus c. Yeah. Okay, let's do the next one. The next one's quick, actually. It's quicker. Okay. Is this our very first, like, area one explicitly? I think so. So let R be the region enclosed by these two graphs. And this is a non-calculator one. And the y-axis on the vertical line x equals 2. Find the area of R. Okay. Which one of these is the cosine and which one is that parabola? The cosine is the bottom one. So this is g of x and this is f of x. Okay. So it's going to be, area is going to be from 0 to 2. 6 minus 2, x minus 1 squared, minus negative 2 plus 3 cosine pi over 2x dx. Okay, so that's a long integrand. I would try to simplify this before I integrate. Right? So let's see what this is. So what would this be? 0 to 2. So this is, how much is that? Let's do that on our scratch paper here.
The top is, sorry, did you mean to write f of x? The top, or is it h of x?
Oh, it's h of x, sorry. Yeah. So here we have 6 minus 2 times x squared minus 2x plus 1. So how much is that? 6 minus 2x squared minus 4x plus 4x minus 2. Right? So how much is that? Negative 2x squared plus 4x plus 4. plus 2 minus 3 cosine pi over 2x dx. Okay, so let's integrate. This is going to be negative 2x cubed over 3 plus 4x squared over 2 plus, okay, do you see how this is 4 plus 2, which is just 6, so I could just do 6x minus 3. Okay, the derivative of cosine is negative sine, so it's plus 3 sine pi over 2x times a pi over 2 here. And it goes from 0 to 2. Okay? So now, let's plug in the 2's. So area is negative 2 times 2 cubed, so that's negative 16 over 3, plus 2 times 2 is 4, plus 12, plus,
Wait, why would it be 4? Because aren't we squaring it first? Why is it 12?
It's not 8.
because yeah, cosine derivative is inverse, negative sine. Oh no, wait a minute, we didn't, I'm sorry, I was, oh no. Sorry, yes, it should be negative. I took a derivative, I was supposed to do an integral. Negative 3 times 2 over pi, right? Sine pi over 2x, right? Negative 16 over 3 plus 8 plus 12 minus 6 over pi. But what's sine of pi over 2 times 2?
2.
That's sine of pi, which is 0. So all that goes away.
Sine of pi over 2.
Right, but it's pi over 2x. Pi over 2 times 2, which is pi. So all that is yeah. So all that is 44 over 3. Okay? All right, and that's a good place to stop.